So today we're talking about a geometric series, and we're going to find the sum just like we did yesterday with an arithmetic. But geometrics are different. So we already talked about they follow an exponential pattern. So if we look at a graph of an exponential, if it is growing, it's getting bigger and bigger and bigger, and it goes up and up and up forever. But if it's decaying, it's getting smaller and smaller and smaller, and it's getting closer to zero for some of them, depending on the graph. So when you're talking about a geometric series, you one grows and one decays. So one of them, like I said, it gets bigger and bigger and bigger. So if you wanted to find the sum, your sums would just keep getting bigger and bigger and bigger. But if it's decaying, your sums will kind of decay to the same number. And we'll look at those. So one of them is if your growth, one of them is if your decay. So if your absolute value of r, so we're not worried about if it's positive or negative. We're just worried about the number itself. If that's greater than 1. If it's greater than 1, is that growth or decay? Growth. Good. So growth, if it's greater than 1, then you can say that the series converges. Okay. So that means it's just getting bigger forever. It doesn't have any limits. It just keeps growing and growing. So, which means it approaches infinity. Okay, so it just grows and grows and grows forever. But if the absolute value of r is less than 1, we know that is decay, and so it's getting smaller and smaller and smaller, so it's called diverging. So the series diverges. Which means it approaches a number. And it can be any number, it just depends on the equation. But it's a number rather than it just going forever into infinity. So we're going to look at two different kinds of series, a finite and an infinite. So first we're going to look at finite. So finite series uses the formula so a finite means that it has a certain number of terms. Okay? So we need the formula, which is S of n. So same thing as yesterday, the sum of n number of terms equals a1, 1 minus r to the n over 1 minus r. So yesterday we needed a1, an, and n. We still need a1 and we still need n, but now we need r instead of a1. So we need to know what is happening each time. And I showed you yesterday that you get this formula on the final exam as well as the one from yesterday. So let's do one. So let's say we've got -5, -10, -20, etc. And we want to find the sum of the first 10 terms. Okay, so for this one, we still need A1, we need R, and then it tells me N already is 10. So what is our first term? Good, -5. And what's happening each time? Good, multiplying by 2. So our common ratio is 2. So then we have all three things, so we just plug them in. So we want the sum of the first 10 terms. And now we want A1 times, so -5 times 1 minus our R is 2 to the 10th power, over 1 minus 2. And so then you just type it in the calculator. I suggest typing it in the fraction, but I'll show you how to do it if you don't want to use the fraction. So if you type in the fraction, it looks like that. And that gives me that. Now, if you don't want to use the fraction, that's totally fine. But what you have to do is put the bottom, the 1 minus 2, you have to put that in parentheses. Okay. If you don't, it'll just divide by 1 and subtract 2. So if you don't put it in the fraction, it's fine. But whatever you have in the bottom, you have to put that in parentheses. Questions? Alright, but sometimes, like yesterday, they won't tell us everything that we need. So, let's say they tell us 4 plus 8 plus etc. all the way to 10, 24. So we need three things. We need A1, we need R, and we need N. So what's A1? 4. What's R? What's happening each time? Yeah, we're multiplying by 2 because these are geometric. So we want to multiply. But do I know which term that 1024 is? No. So we don't know what N is. But we know that 1024 is our A sub N, whatever N is. So now we can do explicit formula. So remember, for geometric, that's AN equals A1 times R to the N minus 1. So then we plug in what we know. So we know AN is that 1024. We already said A1 was 4, our R was 2, but we don't know N, that's what we're trying to find. So in this one, we kind of have to think about what we did last unit. So I have to get this exponential by itself. So what should I do first? Good, divide by 4. So that'll give us 256 equals 2 to the N minus 1. And then what do I have to do if my variable is in the exponent? Good. So we have to change it to a log. So it would be a log base 2, 256 equals n minus 1. So then remember to type that in our calculator, you go math down to the bottom and up 1, log 2 of 256, and we get 8. If you have an older calculator, remember you do log 256 divided by log 2. Either way, you get 8. So if 8 equals n minus 1, what does n equal? Good. 9. Any questions on getting that? So now we can plug it in. So we want the sum of the first 9 terms. And today our formula is A1, which is 4, times 1 minus 2 to the 9th, over 1 minus 2. And then again, you just type it in your calculator. And hopefully you get 2044. Any questions on that? Alright, let's do one more. So let's say this one tells us that A1 is 2, tells us R is negative 4, and it tells us AN is negative 524,288. So in this one, we have the A1, we have the R. So the only thing we need to find is N. And so again, to do that, we have to use our explicit formula since we know AN. So I can say negative 524,288 equals, our A1 is 2, our R is negative 4 to the N minus 1. So then again, we want to get that exponential by itself. So divide by 2. Gives us negative 262,144 equals negative 4 to the N minus 1. And then what do I do next? Can I do the log of a negative? But I can divide both sides by negative 1, which will make them both positive. And then we make it log form. So what do you get when you do log of this? Good, 9. So 9 equals N minus 1, so N equals 10. Good. So then we can find the sum. So we want the sum of the first 10 terms. So 2, 1 minus. Now this one's different because r is negative. You have to put that r in parentheses. So negative 4 to the 10th. Bless you. Bless you. Over 1 minus negative 4. On the bottom it's not as big of a deal. You don't have to put it in parentheses. But you have to put it in parentheses with that 10. Because there's a difference in negative 4 to the 10th and 4 to the 10th. So then we type it in. This. And so hopefully you get this big huge number. So negative 419,430. Questions? Okay, so last unit we couldn't do log of negative. And you still can't take the log of a negative. But the purpose in us doing the log today is to find the term. So remember, when you're looking at geometric, if your r is a negative 4, all that's happening is you're alternating between positive and negative, positive, negative, positive, negative, positive, negative. So the number itself isn't going to change. The only thing that changes is if it's positive or if it's negative. So let's say we would have got right here and one of them would have been negative and one of them would have been positive. If that's the case, just drop the negative and find the log, because you'll still get the same answer. Because again, the positive, negative, that's just alternating. It's not changing the number itself.